Oh, okay, frightened. They're unable to do live. Okay. All right, nice. So we're gonna take a look at applications of differentiation. Anybody remember any applications? To find the gradient function or the gradient tangent. Nice. What's the next one? Right, is using rates of change. And one more. Maximum, minimum, right? Yeah, to find stationary points, something good. So the first one is used to determine the gradient function. Right. Second thing it's used for is to determine maximum, minimum points. Right. And third thing they use them. Well, there are some other things too, but for you, these are the three things that you have to do. Rates of change. Oh, wait, one more. Wait, how did I forget that? One more. There's one more thing that we use the differentiation in. Kinematics. Right? We use it in kinematics. Okay. So we're going to start with the gradient, determining the gradient function, right? So within your number 4, which is differentiation, they will ask you to differentiate something like this. Then they would ask you two of these rules. One is kinematics and one is number 1, 2, or 3. All right. So that's what the number 4 will look like. I think it's 4 or 5. One of those numbers. Nice. Finish. All right. So we're going to take a look at finding the gradient function, right? Right. Let's say I gave you a function looking like that. That function is a curve, right? So at different points, the gradient always changing. So let us say this function is y is equal to f of x. At different points, that gradient is always changing. So we need to find a way to get the gradient at any single point. Okay? To get the gradient at any point, here's what we could do. Right? To get the gradient, what we could do is we could differentiate f of x. Right? And this gives the gradient function. I'll give it the gradient function, right? Second thing you're going to do, we're going to substitute, right? Right here as an x value. You're going to substitute the x value. Substitute the x value at that point. And obtain the gradient of tangent. So when you substitute the x value, oh, by the way, substitute the x value in dy dx, right? substitute it in the gradient function, you will get that tangent, right? Let me just try and draw it here for you. Right, that is your tangent. So whenever you differentiate and plug in the x value, what you're really finding is the gradient of tangent. Anybody remembers how to get a gradient of the normal? Right? Anybody remember how to get a gradient of the normal? The normal is this line here. Perpendicular. How do we get the gradient of the normal? Multiply by, close to it, negative reciprocal, right? Negative reciprocal of the gradient of tangent. Okay. Just one more thing to remember. Well, I really hope you remember this equation of a line. How you find it again? Right, y is mx plus c, or you use y minus y1 is m by x minus x1, right? Let's make a little note of that, because these questions come in that particular form, right? Minus 1 over the gradient tangent. Negative reciprocal, right? Flip it over, change the sign. Yeah, finish. All right, so let's start with one here. Let's start with example number 1. Right, Emily writing online, nice. Okay, good. Right, let's see if we could find the equation. Find the equation of the tangent at 2, 1. On the function y is equal to 5x squared minus 2x plus 1. Right? So you want to get the equation of tangent at that particular point. All right? I'm just doing a quick sketch. I don't know if the quadratic right, I'm just making up something. It might look something like that, right? What they're asking for is at a particular point, let's say here's 2, and here's 1. At this point here, they want the, hold on, I'm gonna make it look a little nicer. Right? At right. At this particular point here, what they would like is they would like the tangent at that point. Okay? So to find the tangent, right? To find tangent, what do we need? To find the equation of tangent, we need 2 things, right? We need number 1, gradient, and number 2, point on the line. So how are we going to get a gradient? We have to differentiate. So y is equal to 5x squared minus 2x plus 1. So dy dx is how much there? 10x minus 2. Right. How do we get the gradient of the tangent? How do we get the gradient of the tangent? All we have to do is substitute the x value, right? X is what? Right? X is 2. So therefore the gradient will be 10 by 2 minus 2. 20 minus 2 is 18. Right? This function here is called a gradient function. So by just putting the x values in, you'll be able to find the gradient. So we know the gradient, we know the point, so we know m is 18, we know x is 2, we know y is 1. So we can find the equation now. Any questions? Any questions there? I know all the writing. Any questions? I'm just going to use the formula now, right? Y minus y1 is equal to m by x minus x1. So that's y minus 1 is equal to 18 by x minus 2. Multiply it out, you'll get y is equal to 18x minus 36 plus 1, which is 18x minus 35. $18x minus 35. All right, so you're taking your time, you find the gradient, you have the point and the substitute. Quick question. Suppose I did not give you the point and I only gave you the x value. How you'll get the y value? Huh? How you'll get the y value? Substitute the x in here, right? The one that says y. That'll give you the y value. Right? Right, Chevelle? You okay with that? Right, so that's substitute the y value, right? Anybody writing online? And we have to pass it a booklet. Yeah? I have nothing to say about it. Ready? Right at training deep, there's 2017. This is 2017, but instead of tangent, they asked it for equation of the normal, right? So I'll write it out for you. Or should I take a little picture right here? Yeah, don't need these slides because I have the video, right? Wait, 5 marks, huh? 5 marks for this. All right, try this here, please. I'm not staying on this application too long. I want to focus on the next one, the next two rates of change, and next one. 2017. Right, they gave you the point and the curve, they want the equation of the, pay attention, and normal. This is not the tangent, obviously. You see it? You know, Azaria, hold on. I don't know which one between Azaria and Elena feeling shameless, which 6 can't say anything. You can see that now? Still? All right, write this down. You can see that now? Right. Just write the point and the function. Elena can't see nothing. She will say nothing and she will fight someday. Pause, you see it? Right there, where you can see. That's supposed to say. Finish? No, just write the function. Yeah, you wrote that. I want to put it back, right? So you're finding the equation of the normal. Take your time. Right, so once you finish, you can message it. Try not to leave it in fractions, right? Right? Remember, it's normal. Huh? Negative is out there. Right. So that's what's right out by 4. All right, let's check it out. So first thing first, we want to find dy dx. dy dx will be 3 by 3, that's 9. 9x squared plus 4x minus 24. Right? Then we're going to check when x is minus 2. dy dx is 9 by minus 2 squared plus 4 by minus 2 minus 24. How much you got there? 4? Positive 4? Right. So this is the gradient of tangent. Now we want to get the gradient of the normal. Right? So all we have to do, flip the value over, change the sign. So it becomes negative 1/4. So we're going to use x is minus 2, y is 0, gradient is negative 1/4. Okay? And we're going to use it in y minus y1 is m by x minus x1. So y minus 0 is equal to minus 1/4 by x minus x1. So y is equal to minus 1/4 x plus 2. Right? Minus 1/4 x minus 1/2. Multiply by 4. 4y minus x minus 2. Yeah? It looks like that. Multiply everything by positive 4. Nice. So that's an easy 5 marks. Right? That's 5 marks in 2017. So if you wrote it in 2017, you have 5 marks in the pocket there. Pause. You okay with that? You have that 5 marks? Huh? Sorry? No. The reason that I do this is sometimes there are questions where you have to use this and now solve simultaneously. So it's always good to just put it down. But the question didn't say simplify all the way, right? Oh wait, this book that don't have all the just have a few years. A few years. Right, one more we done, right? Sometimes it'll be a little more challenging to differentiate, like this one here, 2016. Everybody okay online? Aryan, you okay there? Wait, no, not Aryan. Rian, you okay? Tamia? Tamia, you okay with us? This is 2016, right? I usually 5 marks again, right? Same thing. Try this. Right, for the blind ones, just Write it down there fast. The point is 1,8 and the function is 2x by x plus 1 squared. Who wins sports yesterday? Who wins sports? Louis Maria. So that was it. 2x by x plus 1 squared. Well, it has force in the back. Oh, remember. I'll get you there. Right, go ahead, do this, please. Find the equation and the normal. 5 marks, that's how fast we can do it. Are you all differentiating that, by the way? Chain product. Product rule, right? 2x by x plus 1 squared, right? Or you can expand it out because it's squared. You can expand out if you want. Yeah, expand the square brackets first, usual quad mass brackets first, and then the 2x. Or you can use product rule, right? Not chain rule, right? Because the problem is this, the 2x on the outside, right? So this is like a u and this is a v. Okay, you can expand or you can do that. Ready? So I just checking it. You'll use expansion of product rule. Expansion. So I just checking your expansion out, right? So it's 2x by, when you expand out in there, x squared plus x squared plus 2x plus 1. You'll got that inside the bracket. When you expand, x plus 1 squared is x squared plus 2x plus 1, right? When you multiply that out, you'll end up with 2x cubed plus 4x squared plus 2x. Okay? I didn't really want you to use that technique. I really want you to use product rule, but go ahead, no matter. Sorry? No. When you're using product rule, u is 2x and v is x plus 1 all squared. Just leave it just like that. Right? Remember to differentiate x plus 1 all squared, bring down the power, differentiate the bracket minus y. Yeah. Hmm? No, them have lab. Oh yeah, that one with lab set. Two with lab. So come that's now. Right? Can I start? All right, let's work it out. Right? dy dx is equal to 6x squared plus 8x plus 2. We substitute x is equal to 1, and we'll get the gradient to be 6 plus 8 plus 2, which is 16. Yeah? So therefore, gradient of normal is negative reciprocal, right? So that'll be negative 1 on 16. And now we're going to use the gradient as negative 1 on 16. X is 1 and y is 8. Remember, I told you not all the time they'll give you the point, right? So you have to, if they give you the x value, you got to be able to get the y value. All right. So therefore, you'll have y minus 8 is equal to minus 1 on 16 by x minus 1. That's okay? Right? Then you multiply it out. So you'll get y is minus 1 on 16x plus 1 on 16 plus 8. Okay? All right. I don't really know. I don't really think I can multiply that. So I'll just put 8 and 116. I'll leave it like that, right? Yeah, but then remember it to be 8 on 16. What is that? What's 8 on 16? 129 over, right? And then multiply everything by 16. Oh, crap. You know, when I want to do a screenshot, it doesn't work. So if you multiply everything by 16, you'll get 16y is minus x plus 129. All right. Okay, good. Next application, stationary points, right? Any questions online? Amanda, you got 14. Check back here. What you got for the gradient? 14, 6 plus 8. Yeah, just check back your working there. The gradient is 16, right? Okay. Right, Amanda, just check back your gradient there. All right, last application for today, right? Stationary points and their nature. Huh? Purple, that's purple. 1 year you win. 1 year we had win, huh? I am a 1 year we had win. Oh, not that year we had some athletes something. I think purple is always win cheerleading long time. All right, let's start. Right. So we're taking a look at getting stationary points and their nature, right? So the first thing we need to remember is that if I give you a quadratic, right? This point here is a stationary point, right? So to obtain this stationary point, right? Anybody could tell me what they recognize about the gradient at that point? I try and draw a line there. What you all recognize will be the gradient there. It's a horizontal line, right? Very good. So therefore, the gradient is 0. So it means that dy dx is 0, right? That's the way you find stationary points. So when dy dx is 0, right? When dy dx is 0, stationary points occur. All right, when dy dx is 0. And if you find dy dx, d2y dx squared, if d2y dx squared is more than 0, then we have a minimum point. If d2y dx squared is less than 0, then we have a maximum point. And that's it. That's all we need to know about finite nature. Copy down. So again, you see how important it is to differentiate and double differentiate, right? I'm not sure if I did double differential and that on that day. Right, but double differentiation is just differentiating one more time, right? Huh? On the Monday? I don't think I do it on the Monday. Yes, second order derivatives, yeah. What's that? If I'm doing this Monday, no, Monday I will do rates of change because that's what you'll do. Like, remember Monday's division. So Monday I'll do rates of change and probably just rates of change and kinematics. Or shocks. Yeah, I'll do rates of change. I'll do rates of change Monday. Oh no, or the integration. Probably the rates of change. All right, let's try an example. What's that? Oh, okay, okay. All right. Right, so example 1. Right, so if y is equal to, let's start easy, right? 5x squared minus 2x plus 1. Right? Let's see if we could find the stationary value. Find the stationary value and determine its nature. Nature, that means if it's max or min. Right, so step number 1, we find dy dx. Step number 1, we find dy dx, which is 10x minus 2. Next step is what? Next step, we're going to let dy dx equal to 0 to find stationary point. So we're going to get 10x minus 2 is 0. X is 2 over 10 or 1/5. Right? X is 1/5. Okay with that? We need to get the y value as well, right? So that's 5 by 1/5 squared minus 2 by 1/5 plus 1. Anybody can help me out there? Four fifths. Huh? 4/5. So that would be 1/5, 4/5, right? That's the stationary point. To determine the nature, we have to find d2y dx squared. When you double differentiate this here, what you'll get? 10. Very good. 10. Is it more than 0 or less than 0? More than 0. Right? d2y dx squared is more than 0, therefore is a minimum point. That's it. That's the way you do these questions, right? Copy it down. So you find dy dx and you double differentiate, right? Yeah, hey, a class going here, just come here. No, move now, move fast. You can just walk and do that. In 5 minutes, you can come and do that. Right? Let's try 2018 quick. Right? 2018. Right? I want you to find the stationary points and their nature, right? Find the stationary points and their nature. Right? Find the stationary points and their nature, right? Right, so I just check in your two differentials, dy dx, 3x squared plus 4x, and then d2y dx squared is 6x plus 4. That's okay? Right, those are your two differentials, right? Right, when dy dx is equal to 0, that'll be 3x squared plus 4x is 0. You can factor out x. Right, so the two stationary values are x is 0, what, and x is 4 and minus 3, minus 4 and 3. Yeah. I just do the second differential for later on because I'm doing the whole question on this page. Right, but no, in part 1, you don't have to do that. Yeah. I just doing it because I'm going to use it in the second part. When x is 0, y is minus 1. When x is minus 4 and 3, what was y? Take it from me now, please. When x is minus 4 and 3, what y'all got for y? Any answers online? What y'all got for y? When x is minus 4 and 3. 5 and 27, thanks. Right, so these are your 2 points here, right? Now you want to get the nature. When x is 0, d2y dx squared is 0 plus 4, which is more than 0. So therefore, that's a minimum point. When x is negative 4 and 3, d2y dx squared, right? d2y dx squared will be 6 by negative 4 and 3 plus 4, which is a value less than 0. Therefore, is a maximum. Right? That's all they're doing, finding the max and the minimum points. That's okay? All right. So that's the